Are you thinking about design for additive post-processing? Let's talk about PostProcessing Technologies connected software next. All right, so let's talk about design for additive post-processing, which is different from design for additive. So let's rewind a little bit so we have a little bit of context. So there have been DFX initiatives, so design for X, where X can be a lot of different things. There have been initiatives focusing on that for decades. Design for manufacturability is a big one. We're looking at the design to see what adjustments can be made so that it can be manufactured more easily at a lower cost, so on and so forth. Design for reliability, design for quality, any kind of enterprise concern that you could possibly take into account, you can kind of put it under the umbrella of design for X, DFX. Most recently, we've been talking about design for additive. So as you have a bed of material and you shoot a laser and you heat up, either basically a plastic or a polymer or a metal, that will cool down, right? And as things cool down, they shrink, right? So for additive, we actually talked about this capability in some software recently. How do you kind of reverse engineer that so you actually make it with additive materials bigger than they actually are, so that when they shrink, they're the actual thing that you want? Well, when you think about additive, rarely do you have a part that ever comes out of the printer that is exactly the way you want it. There's all sorts of support structures. And also, as you make a part in a 3D printer or through other additive approaches, you're not going to have the surface finish that you want. Enter PostProcessing Technologies. So this company, PostProcess Technologies, allows you to basically automate and standardize the post-processing procedure, so it's not done by hand, it's actually done in a machine, right? So this is where you take a part out of the 3D printer, you put it in this other one, and it will basically do everything you need to that part so that it achieves the quality that you want in terms of a surface finish, in terms of removing the support structures, and what have you. So they have some good solutions there. And if you think about it, if you're ever going to take additive to production, you're going to have to automate that last step. Just like quality steps are automated in today's manufacturing processes. So, how does that lead to design for additive post-processing? Well, there are adjustments you can make in the design process by engineers that will improve the outcome in the post-processing process. You can, especially setting it up for 3D printing, you can change the orientation so the support structures are a little bit different. If you need to have certain surface finishes where there are support structures, if you reorient it, you can make it so that there are no support structures going into that surface, so that when you remove those, you don't have some variation in the surface finish. There are also things like taking the chemical properties into account that you're going to be using to post-process the additive component. All of this stuff goes into this software, and it's used by engineers up front, and it's called connected, except no E, uses a 3. So that connected software offered by PostProcess Technologies can be used by engineers all the way up front to make adjustments to the design so that when you do go through the additive process, it comes out as you expected. More easily, more readily, reduce costs, reduce maybe even the processing time, and you have a better outcome overall. So that's it. So if you're in a company that's serious about 3D printing and additive for production, maybe even for prototype parts, this is important, and quality is an issue, then you might want to take a look at this. It really might be applicable to what you're doing. That's it. Take care and talk soon.